Hello friends and dear student. Today's lectures on neuroglia. In last lecture we talk about the histology of nervous systems. In histology of nervous systems we describe that mainly nervous systems made up of two types of cell. First one is neuron, which is truly cells. We can say it's a structural and functional unit of nervous systems, that is neuron. We already described the neuron in very detail, but today we talk about the neuroglia. Actually, neuroglia, its name suggests neuroglia. Glia means, it's a Greek word, means glue. Glue means it's sticky material, means they stick the neurons to each other. Though it's a very former thoughts about the scientists or doctors, it's not now true. It's only glue, but it's a more many other functions. Also, neuroglia called as a glial cell, or also we simply it's called as a glia. It's a three name: neuroglia, we call it as a glial cells or glia cells. It's a difference from neurons. It's a mainly most important difference from neuron. That is, it's a non-excitatory cells. They cannot generate the action potential. Not generate action potential, or they cannot generate impulse. Means it's a non-impulsive cells. So generally we thought that the neuron is a truly cells. They can generate the action potential, but neuroglia cannot generate the action potential. So it's a non-excitatory cells, non-impulsive cells. Today we talk about the neuroglia in a detail. First we talk about the some history, then talk about the some basic main functions of all neuroglia cells, generalized functions. Then we talk about the different types of neuroglial cells, and then we talk about the functions of each types of cells. Then we further describe the astrocytes in a very detail. Though neuroglia cells and neurons are discovered at a parallel times in a starting of 19th century, but neurons are nowadays neurons have a well established, well studied cells, but majority scientists or neurophysicians or pathologists, they forget about the neuroglia. They are underestimated because they thought this is the only glue materials, this is the only supportive, or they only the glue materials, but it's not like that. First times of neuroglia cells are described by in a 1856, a pathologist, German pathologist named Rudolf Virchow. This is the German pathologist. We discover the nervous system's histology for a connective tissue of CNS. We actually know there is some, in majority organs there is some connective tissue. So they also want to find the connective tissue of central nervous systems. That time they find out a glue-like cells, means a cells which act like a glue, which bind the neurons. We integrated the neurons. They maintain the positions. It's a, they give a name a glial cell, neuroglia cells. Glia means glue. It's a German word. Now this this person's Rudolf Virchow, it's a nowadays it's a known as a father of modern pathology. It's a pathologist, so it's a father of modern pathologists. So it is a, basically it's a German pathologist. They discover many other things, but they in 1856 they differentiate the neuroglia cells first time. But after that, many years, means now we are in a 2020, so after many years scientists forget the about the neuroglia cells. Even some book till now, in some books this neuroglia cells are underestimated. Some authors not even describe the neuroglia cells. But now a recent study from 20 to 30 years back, means recently here, now neuroscientists or pathologists or doctors who research on neuroglia cells, and they find out neuroglia cells are not only the limited supportive or glue like functions, but their functions are more. So now we talk about the functions in a general functions. But before that, I give some interesting fact about the neuroglial cells. The interesting fact, there is a difference between neuron and neuroglia cells. Neurons having a very few functions, means they are only functions of action potential, few functions or limited functions. We talk about the neuron here, and here the glial cell or glia. So it's very few functions neuron, but glia having they shows the variety of functions. They only not only one functions, the variety of functions. Then we talk about the size. Generally, glial cells having a smaller size than the neuron. It's a bigger or larger. And you can say it is excitatory cells or impulsive cells. They can generate the action potential, and they cannot generate the, we talk about the action potential, it is generated, they cannot generate the action potential. Okay. More functions about the neuron and glia. What is the difference between neuron and glia cells? There is a numbers are less in CNS, but number as per number it's a more than the neuron, more in number. Then neurons cannot multiply, they lost its capacity to multiply. Okay, so meiotic capacity or multiplications cannot take place. Multiplications cannot take place. Here the multiplications takes place. So this is about the very basic difference about the neuron and glial cells. So, but recent study shows, as per numbers, neuroglia cells and neurons are equally in number. Though in some books, in older authors, they believe that neuroglia cells are 5 to 25 times more than the neurons. But recent study, they shows numbers of neuron and neuroglia cells are generally 1:1, means it's equal in number. This is a very recent study. And neuroglial cells are present in a different part in a different numbers. Like examples, they are more in cerebral cortex. Suppose we talk about the cerebral cortex, where glial cells is more. Glia is more than the neuron. Why? We talk about the cerebellum, where neuron is more than the glial cells. So these glial cells are shows in a different distributions. Some in brain, in central nervous system, some area having a more glial cells than the neurons, but in some area there is a more neurons than the glial. So this is the variety. This shows the variety. When there is a one more things, neuroglia cells are also evolved from same tissue, like when neurons are developed. We know there is a all nerve systems are developed from ectoderm. So neuroglia cells are also developed from ectoderm. But there is a evolutions fact is there, or evolutions record is that not only the numbers increase, not only the numbers increase of neuroglia cells in a human beings, but also there is a size is also increase. Volume or size is also increase from lower animal to human being. We can see there is a, if you take the neuroglia cells in a mouse or rat, it's a, then the human, Human having a 16 times larger volume of neuroglia cells than the rat. So by evolutions, this volume of neuroglia cells are also increase. Not only the numbers increase, but as well as size is also increase. But this all study are developed in a very recent year, because through now persons or scientists only believe that glial cells are supportive cells, they are connective tissue, there is no other functions, some physical functions. But recent studies shows neuroglia cells not only for physical support or physical functions, but they have some physiological actions also. They establish some actions in a disease conditions. They shows that there is a many disease conditions that neuroglia cells having a very much prominent effect. So recent scientists or recent neuroscience, they are more concerned about the neuroglia cells, so they are more research. So it is under still research, so we have not 100% study of neuroglia cells, but whatever study is done, we will talk here. One fact is that a great scientist, that is Albert Einstein's, we know we preserve the brain of Albert Einstein. So scientists find out that neuroglial cells numbers are more in left angular gyrus. This left angular gyrus, are responsible for mathematic, logic, analysis, also for language or many other functions. So they find out the number of neuroglia cells, means especially astrocytes. They are more in number in the great brain of Einstein. So they thought it's maybe having a extra intelligence or extra higher functions due to more number of neuroglia cells. So neuroglia cells make a connection between the synapse. They also make a connection between the blood-brain. They also blood capillaries. They also make a connection between the pia matters of meningeal. So they thoughts only, but apart from other features cannot different from local or other ideal brain. So this is not only one. This is only one changes seen in a brain of great scientist, that is Albert Einstein. But it is only one things. They cannot be. We cannot give a that much important. But this is a shown that they having a more neuroglia cells than other ideal brain. So this is about the study or history about the neuroglia cells. Now we talk about the very basic functions. Basic functions of neuroglia cells. First, we all know about from the names. Glials means glue, means they are responsible for support. First functions is they give a support to neurons, means physical support as well as chemical supports. How chemical supports we will discuss. They maintain the chemical environment around the neurons. They maintain the homeostasis. So second functions of neuroglia cells, they are maintain the homeostasis. Homeostasis. Next functions, they are responsible for formations of myelin sheath or myelinations. So we call say myelinations. What is myelinations? Myelinations means they develop a myelin coverings around the long axons. So they are due to myelinations, they give a insulations. What is insulations? Insulations means we know there is in our normal wiring, electricity wiring, it's made of a copper, so we wrap the rubber cover. So they two wires cannot connected, they cannot get a cross connections. So for that they differentiate the two axons. So two axons cannot connected and action potential cannot mix. So this is they prevent this mixing of action potential, mixing of electric impulse. So they give insulations, but myelinations also give a increase the velocity of action potential. So this is they give a myelinations. Third functions, they are also responsible for protections, protection functions. Protections by they form the forming the blood brain barrier. What is blood brain barrier? It's not a anatomical barrier, but it's a physiological barrier. We will discuss the blood brain barrier in a detail, but right now I explain a very simple. Suppose this is the central nervous systems, or this is a tissue of CNS brain. So you know there is a blood supply to the central nervous system. So we can draw like this. So all substance cannot cross and go into the CNS. Some selective substance can only cross the this barrier. Here some barrier. This capillary made suppose this is a capillary. They made some special barrier with a form a tight junctions between endothelial cells. So not all substance cross this barrier. So this is actually for protections. So brain cannot affected by all substance which is present in capillary or in blood circulations. So it is a preventive protective barrier between the blood and brain. So this is called as a blood brain barrier. It's not like a physiological barrier which is it's not anatomical barrier, sorry, it's a physiological barrier. Also how they protect, you know, there is some special neuroglia cells having a defensive activity like a phagocytosis. So they defense from pathogens, some foreign materials. So some glial cells having a phagocytic activity, they shows the phagocytic activity. So they are responsible for defense means protections from foreign particles and pathogens. One more functions, they are responsible for repair injury, repair neuron injury, as well as they are responsible for growth of neuron, growth of neuron during embryonic life. So when there is a development of neurons during intrauterine life, this neuroglia secretes some peptides, neuron growth factors or peptides. They are responsible for neuron growth. So if there is if lack of these peptides, neuron growth peptides, so the development of neurons become inhibited. They are lack develop. So they also produce some deformity. So they are responsible for repair neuron and also responsible for growth of neuron during embryonic development. Also they are responsible for they are reuptake the clearance, we can say it's a clearance of neurotransmitter, clearance of neurotransmitter. Whenever a neuron secretes the neurotransmitter, they have to they have to remain for some time. After sometimes they have to either they are deactivated by some special enzymes or either they are reuptake by some special cells. So this neurotransmitter are reuptake by a neuroglia, especially astrocytes. They reuptake the glutamate, they reuptake the GABA. So if neurotransmitter remain for long times, they give a excessive actions, a long time actions, because they remain present in synapse for long times. We don't have these actions. We required only for few times. After some times they have to be clear up from synapse. Also they maintain the chemical environment, or we can say ionic balance. Ionic balance means surround the neurons, means we call as a internal environment of CNS. They are maintained. Ionic balance are maintained by neuroglia, especially level of potassiums. They are maintained by neuroglia. One more functions that they also give a oxygen and nutritions to neuron. So this is all a common functions. We talk about the common functions. First function is support. They give a physical supports by making a connective tissue. They making a network with a blood capillary, with pia-matters, with axons. So they are responsible for physical and chemical supports. Second is they maintain the homeostasis of central nervous system. Also give a myelinations, means insulation functions, not insulation functions, but they also give a increase the velocity of action potential. They give a protection functions, like they make a BBB, blood brain barrier, and they having some phagocytic activity, some neuroglia cells having a phagocytic activity. Also next is a repair of neuron injury. When neuron get injury, they neuron cannot multiply, but this injury are repaired by neuroglia cells. Also they are responsible for growth of neuron during intrauterine life. Next functions, they give oxygen and nutrition to neuron. They clearance of neurotransmitter from synaptic left and chemical ionic balance, especially potassium. So after break we talk about the different type of neuroglia cells. Having a break.